Let's simplify this fraction. When I say simplify, it usually means you can cancel some stuff, right? And it's really tempting to cancel these 5x's, but that's not allowed. And you can check that indeed such a cancellation cannot be done if you do work with some examples, like in fractions, if you have 1 plus 2 and 3 plus 2, and it's really tempting to cancel these 2's, but what is this? 1 plus 2 is 3, 3 plus 2 is 5, so that is equal to 3 over 5. If you try to cancel these, you will end up with 1 plus 1, which is 2, 3 plus 1, which is 4, and that's not same as 3 over 5. So even though 2 divided by 2 is 1, and it's tempting to write 1, 1, that is not allowed if you have additions like that, okay? So let's try to see what can be done here. You can only cancel things if you have some factors, overall factors. If you can factor the top and bottom, and you have some common factors. If you have common factors, if these two are the same, then you can cancel. So that's basically the idea that we have, and that means we really need to factor this 2x squared minus 5x plus 3. How do you factor this? Well, the generic method for this is called factor by grouping, factoring trinomial with grouping, or factoring a quadratic polynomial by grouping. That's what you should look for. There should be tons of videos on this, but hopefully you know this. So you can use factor by grouping. However, also notice that 2 minus 5 plus 3 is 0, right? 2 plus 3 is 5, 5 minus 5 is 0, right? And if that happens, if your coefficients just add up to 0, there's a shortcut you can take, and this is in general a principle called factor theorem. So what's a factor theorem? Well, if you plug in some value into x, say for us it's 1. If you plug in 1, because the coefficients add up to 0, if you plug in 1 instead of x, you get 2 minus 5 plus 3, which is 0, right? So if such a thing happens, then this polynomial will have a factor of x minus that number. So x minus 1 should be a factor of this polynomial. Okay, this greatly simplifies what the other one is, because we know that x times whatever this is, it has to create 2x squared. So what else can it be but 2x, right? 2x times x is 2x squared, right? And also negative 1 times this number should equal to positive 3, so what else can it be than negative 3? Now it remains to really check that indeed these two are the same. How do you check? You can FOIL this out, right? X times 2x is 2x squared. X times negative 3 is negative 3x. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is plus 3. And as you can see, 2x squared minus 5x plus 3 is indeed what you get if you expand it. So we can say this above fraction, at least the top part, can be replaced by x minus 1 times 2x minus 3. Now, do you notice that indeed the bottom one also has this property? If you have 3 minus 5 plus 2 is 0. So again, we can play the same game and say 3x squared minus 5x plus 2 is equal to x minus 1 times something. And what is that something? X times 3x should give you 3x squared, and negative 1 times negative 2 should give you positive 2. And I'll leave it to you to check that indeed if you expand this, you get this left side. So the bottom becomes x minus 1 times 3x minus 2, and x minus 1 cancels, and you get 2x minus 3 over 3x minus 2. Okay, so we have simplified this fraction. Now, there is a warning though. So if you think of this as a function, and this is another function, these two functions will agree in any value that you plug in. So let's say if you wanted like f of 0, what is f of 0? You plug in 0, everything will be 0, you'll just get 3 over 2, right? And indeed, if you do g of 0, you get, when you plug in 0, 0, you get negative 3 over negative 2, which is, if you multiply negative 1 top and bottom, you get 3 over 2. So you do get the same value, except that these two are different when you try to plug in f of 1. So f of 1 is undefined because if you try to plug in 1 in the denominator, you get 0 in the denominator. F of 1, you end up with 0 over 0. And whenever you have 0 in the denominator, you say that number is undefined. Whereas g of 1, that's perfectly fine. If you plug in 1 in here, you get 2 minus 3, which is negative 1. And down here, if you plug in 1, it's 3 minus 2, which is positive 1, so you get the value of negative 1. So although we said this simplifies to this, and we usually think of these two as algebraically equivalent, you have to know the distinction between these two, that this one you're not allowed to plug in x equals to 1, whereas this does. So their domains are different. So that's what I want to say. Okay. So the warning I wanted to say. So let's see. So here's the answer. So this here is the answer. And the warning I want to say is fx and gx have different domains. Okay, domains are like numbers that you're allowed to plug into these functions. These expressions, you're allowed to plug in anything as long as it doesn't make the denominator 0. So for this one, you can't plug in 1 or let's see, 2/3. 2/3 will make this one a 0, right? 3x minus 2 equals to 0, 3x equals to 2. So 2/3 will be something that's not allowed. So both of these functions do not allow 2/3. But this one actually has one more prohibition, which is x cannot be 1. So they have different domains. Okay, so gx allows more values. Okay, let's move on. So just keep that in mind, because that sometimes comes into play. Okay, let's move on to the next one. Here, unfortunately, if you do 2 minus 7 plus 6, it's not equal to 0. So here you really need to factor by grouping. Okay, so let's do factor by grouping. How do you do that? Well, first, to factor 2x squared minus 7x plus 6, you multiply the first and last, which gives you 12. And you look for two numbers who add up to the middle number, including the minus sign, and whose product is this product that we just figured out. And because two numbers multiply to positive, it has to be either plus plus or minus minus, but their sum is negative, so it must be negative negative. Okay, so it's good to first determine whether A is positive or negative. So A is negative and B should also be negative. And then what two numbers multiply to 12 and add to 7? Well, 3 and 4, right? So it must be negative 3 and negative 4. So we see that negative 3 plus negative 4 gives you negative 7. And negative 3 times negative 4 indeed gives you positive 12. Once you figure this out, factor by grouping method, that would be step 1. And then the step 2 would be to rewrite this so that negative 7 is now replaced by negative 3x and negative 4x. So negative 3x minus 4x plus 6. So you do it like this. And then, so make sure that these are indeed the same. If you collect the like terms, negative 3x minus 4x will be negative 7x, right? But we did this hard work in order to factor the first part and the second part by grouping. The common factor between these two terms is just x, so we factor the x out. And the common factor, they're both even numbers, so 2 is a common factor, and if you have a minus, you should include that too. So it's negative 2. times 2x. 2x times negative 2 is negative 4x, and then negative 2 times negative 3 gives you positive 6, right? If you did it correctly up till this point, then you will see that these two are indeed the same. So you can factor that out. You can take that away from these two terms, and what's left once you take these out, you're left with x and minus 2. And you can also check that if you FOIL this out, let's FOIL it. X times 2x is 2x squared, x times negative 3 is negative 3x, negative 2 times 2x is minus 4x, negative 2 times negative 3 is plus 6, negative 3x plus negative 4x is indeed this. So indeed this is equal to the original one, right? So that's how you factor by grouping. Okay, so you have x minus 2 times 2x minus 3. Okay, so let's do another one of these here. 2x squared plus x minus 6. Multiply these two, you get negative 12 again. So we need two numbers that multiply to negative 12, and then a plus b should be positive 1. Now this, if you have a product that gives you a negative, that means one is positive and the other is negative. Okay. Yeah. So one of them should be positive. We'll call the positive one as A and negative one as B. So really what's happening is that you're subtracting the two rather than adding the two. Okay. So if you subtract the two numbers, you get 1, and if you multiply the two numbers, you get 12. What are those two numbers? Well, again, 4 times 3 gives you 12. 4 minus 3 gives you 1, right? So we see that 4 plus negative 3 is 1, and 4 times negative 3 is negative 12. And therefore, we see that this has to be factored by grouping as 2x squared plus 4x minus 3x minus 6. Okay. So I split the middle term as 4 and negative 3, and indeed if you simplify this you get the same thing, right? And then you factor the 2x out, and the second one you factor the negative 3 out, and finally you have 2x minus 3 times x plus 2. So here you have x plus 2 times 2x minus 3. You can change orders, right? And as you can see, these two are the same. Although these look very similar to each other, you cannot cancel them. Even if you have 2 and 2 here, be sure not to cancel them, because you have minus and plus that forbids these two to becoming canceled. Okay, so you have 2x minus 3, 2x minus 3 canceled, and you get x minus 2, x plus 2. So that's the answer.